Okay, so we're moving on to 8.1, which is polar coordinates. So here for part 1, it says 3 comma 5 pi over 4. Okay, so where's 5 pi over 4? It's in the third quadrant. If r is 3, so I'm on the third circle counterclockwise until I get to the point 3 comma 5 pi over 4. Okay, awesome. For the second part, it says 4 comma negative 7 pi over 6. This is one of the questions from the exit ticket, well, at least the theta. Remember that you can find a coterminal angle by adding 2 pi, right? And that gives us 5 pi over 6. And so where is 5 pi over 6? Well, pi over 6 is over here. The next one in the second quadrant would be the 5 pi over 6. And because it's positive 4, you're on the fourth circle, counterclockwise, until you get to 5 pi over 6, okay? We have spoken about when r is negative, it's in the opposite direction. It's a ray in the opposite direction from the origin, and then therefore it would be in the quadrant diagonal to it, okay? I've mentioned this before in class, but if you're in the first or second quadrant and you add pi, of course you're still going to be within one unit circle, so it's going to make sense in terms of the unit circle. But if you're in the third and fourth quadrant and you add pi, that means you've already completed a full revolution and now you're back to the first quadrant, but your theta may not make sense in terms of the unit circle, because the unit circle is just one revolution, right? So if you really want to check your theta and make sure that you're in the right spot when you have r is negative, then what you can do is that you can actually subtract pi, and then therefore you would get an angle that makes sense in one regular unit circle, okay? So that's just something that I've been wanting to mention, okay? So I'll give you an example. So we'll work with this one, part A. So part A was plot 3 comma 5 pi over 4, okay? Let's say, for example, I want you to plot negative 3 comma 5 pi over 4. We know that's going to be the opposite direction, right? So that's going to be up here in the first quadrant. I have the ray going the opposite direction from the origin, and I have the point that I need, right? Again, 5 pi over 4 doesn't make sense to be in the first quadrant, okay? But remember that technically this is a distance of pi. So 5 pi over 4, instead of adding pi, right? Wait a second. Okay. I'm going to go ahead and subtract the pi. Of course, you need common denominators. And so then it would make sense in terms of where I'm at. So if you really want to check where that spot would be pi over 4. Okay. Okay, but again, you know how to do that. We've already gotten used to make your r positive, find where your theta is, and then if you need r to be negative, just go in the opposite direction, which would be the quadrant diagonal to it, and then that will be the spot, label it, okay? But this is just to show you how to get an angle that makes sense when you have plotted a negative r, right, in the opposite direction. Right, so feel free to do that to check yourself. Instead of adding pi, which is 180 degrees, you would just subtract pi, essentially going the opposite direction, and then you'll stay within the one unit circle, and then your answer will make sense in that quadrant. Okay, so the next part is 7 comma 3 pi over 2. Okay, we can find that. 3 pi over 2 is right here. It's 270 degrees, and then 1, 2, 3, 4, 5, 6, 7. 7 circle all the way up to 3 pi over 2. Okay, so label it. And then it's asking you two things. It's saying, can you find 2 more polar coordinates with r greater than 0 and r less than 0? So for part A, we're keeping R positive, and we need to find two more polar coordinates that are equivalent. So we're going to keep R as 7. Okay, and since we already found the 3 pi over 2, we can just find a coterminal angle. So we're going to subtract 2 pi, which is the same as 4 pi, and we're going to add 2 pi. And this will give us equivalent values with R still being positive and essentially in the same exact spot. Just another revolution counterclockwise or another revolution clockwise, right? So in both directions. All right, cool. So that's that. And then part B is, can you say when R is negative? Well, when R is negative, such as -7, now we're 1, 2, 3, 4, 5, 6, 7. Now we're up here, right? We already know that this is pi over 2, right? So I'm gonna erase this so we don't get confused. So it's pi over 2. Okay, again, if you didn't know what that point is, which we do know that that point is pi over 2. Then remember that to get, when you're going in the opposite direction, you are 180 degrees in the opposite direction, so you would subtract pi. So 3 pi over 2 minus pi is pi over 2. Again, remember I told you that if you're in the 3rd or 4th quadrant, it makes sense to subtract pi so that it makes sense in terms of the unit circle. So if I'm subtracting pi, I'm getting pi over 2, which we know that that's that point. So that's one of my answers. Okay, and then how do we get the other one? Well, we'll find a coterminal angle for that value. So coterminal angle to pi over 2, let's go ahead and let's subtract 2 pi, which is -3 pi over 2. Okay, so those are our two. Again, there's more choices. You could have also added 2 pi and gotten a different angle as well. Okay. Okay. Okay, next ones. I might not be able to do all of them, but I'll do 2 of them. So it says convert the ordered pair in polar coordinates to rectangular coordinates. Okay. Remember, rectangular coordinates is our normal coordinate plane. So basically all I have to do is plug in. So here they're giving me 8, 5 pi over 6 as my r and my theta. All I have to do is plug in. Okay, so I'm gonna go ahead and plug in. So it's gonna be 8 times cosine of 5 pi over 6 is x, and y is 8 times sine of 5 pi over 6. You need to figure out the coordinates in the unit circle for 5 pi over 6. Negative square root of 3 over 2 and 1/2. Alright, so cosine of 5 pi over 6 is negative square root of 3 over 2. And then again, you have to multiply by that 8, so don't forget the 8. While y is 8 times sine of 5 pi over 6. Okay, where sine is positive in the 2nd quadrant, so that's just 1/2. Okay, so we did it. We're getting our x is -4 square root of 3, and our y is 4. Okay, you don't have to plot it to check it. Okay, but we do want to write it as an ordered pair, x comma y. Right, because now we have a regular ordered pair in the coordinate plane. Okay, for 24, you guys can plug in and get the answer. So and then that shouldn't be hard to find. Find where the x and y coordinate of 2 pi over 3 is and get your x and y. Okay, but we can do number 25 together. Again, you can pause this, go back, rewatch it. Hopefully it's helpful to those of you that watch it, study it, appreciate it. Okay, so here we have negative 1.2 and 5 pi over 4 for my r and my theta. Okay, so let's plug in. So now for this one, and again, which number am I on? I'm on 8.1, number 25. Skipped. Okay, so you just figure out what the cosine and sine of pi at 5 pi over 4 is. So here we have pi over 4, 3 pi over 4, and here we have 5 pi over 4. Okay, so what would be these coordinates? Well, in the third quadrant, cosine is negative and sine is negative. Okay. So here we're getting negative 1.2 times another negative square root of 2 over 2 for x. And for y, I'm getting negative 1.2 times sine, which is also negative square root of 2 over 2. Okay, so x and y values are exactly the same. So my ordered pair would be 0.6 times the square root of 2, because I can at least do 1.2 divided by 2, right? The numbers can be divided. Of course, the square root has to stay by itself. And of course, a negative times a negative is a positive, right? So we're getting our coordinate or ordered pair, x comma y, in the coordinate plane, is what I meant to say. Okay, so that's number 25. Okay, these are simple as long as you're doing it correctly. So if you're going from polar to rectangular, that means you're trying to find x and y, so you're using the formula. X is r cosine, while y is r sine theta. Okay, of course, if it's the opposite, then you have to use different formulas. So the opposite, which is the most interesting type, is to turn from rectangular to polar. So to turn rectangular into polar, which is x comma y, into polar coordinates, which is r comma theta, then we have to use the fact that r squared is x squared plus y squared, and tangent theta is y over x. So let's just plug in. So for this one, we're going to do number 33. Number 33, again, if you have questions on the other ones, you can just send an email or reach out to me, or you can look it up online as well. Okay, so here we have, we're given negative 3 comma 3 square root of 3. We're told that this is rectangular, and we need to put it into polar. Okay. Cool, so let's plug in. So this is going to be, let me use a different marker, even though I like red. So this is going to be r squared equals x squared plus y squared. Okay, we did something similar in our exit ticket. Okay, so negative 3 squared is negative 3 times negative 3, which is 9. And then we have to square 3 times the square root of 3. Okay, so 3 times 3 is 9, and then the square root of 3 times the square root of 3 is the square root of 9. So this is simply 9 times 3, which is 27. Okay, so multiply the numbers in the front, then you can multiply the ones in the radicals, and of course that's just simplify. Okay, so this is 27 plus 9. And since it's r squared and I want r, I need to square root both sides. So this is going to be the square root of 36, which is 6. Okay, we talked about it. It says here that they want r to be greater than 0 in the instructions, but otherwise remember that when you square root, you're getting positive and negative answers. So technically R could be positive or could be negative. And in the exit ticket, we gave coordinates for both. In this case, they only want to be R to be positive, so we're only going to go with 6. Okay, so far we have our R of 6. Okay, but we still need to find our theta. So theta is going to be tangent of theta is y over x. Okay, so these threes cancel, and I'm trying to figure out where does tangent of what angle theta gives me negative square root of 3. Okay, you could put the negative on top, right? As long as you have one negative. So, okay,